Okay, welcome to this video. There may be cases where you do an experiment, it's thoughtful, it's creative, it's out of the box. You have all these great controls that you've looked at, all of this great data, you've collected not just over 10 values of the independent variable, but 15. And you didn't repeat each trial just 3 times, you did it 5 times. All of this preliminary work that you did to make sure your method was good. And yet, what do you see at the end? Data which cannot be linearized. And like steam is coming out of your ears, right? There's your steam coming out of your ears. You're gritting your teeth. Things are not looking good. In this video, I'm going to show you a couple of strategies you can use to still make progress and go forward through the report. All right then, the first thing that you can do, right? Let's say you have some data. Here's your independent variable and your dependent. And of course, whenever you do an experiment, you're always going to try a log-log analysis, and you're always going to try, if that fails, a semi-ln analysis. Even when these analyses fail, even if not fruitful, even if you don't get a straight line, you still include those in your report. After all, that's work that you did. That's good scientific work and analysis. Just because you didn't get results that are nice and neat doesn't make the analysis invalid. The analysis still applies. There are still conclusions that you can draw. So draw the conclusions, like not a power function. Justify those. Draw the conclusions like not an exponential function. So this is good work, scientific work we can do even with data that doesn't seem to follow a single trend. So let's get back to the graph which I started. What do we do in the case where your dependent variable is here and your independent is I? There's a couple things you can still do to kind of get a sort of straight line in the event that your data doesn't seem to make one single trend. The first thing to try is, let's say our data looks like this. Right? Some kind of cosine shape. See that? See how the data is going up and then down like that? If you suspect some sort of trig function, then you can just sort of guess and check. Try making a graph with d versus log, d versus cosine, or sine in this case, sine of I. Or try a graph, try a graph of d versus cosine of I. Or d versus sine of, you can guess a constant. You can guess like pi I or something like that. Or cosine pi I. The pi thing, that probably won't work. So actually, maybe don't waste your time. Maybe don't waste your time trying this. So try those two things. Or you can do d versus, tangent I. Or you could also do, instead of taking the tangent or sine or cosine of I, you could do the cosine, sine, tangent of d. Right? You could do sine d, which amounts to d versus arctan, or arcsine. So in Excel, that's what you type. You type a sine equals a sine, and it's just inverse sine. D versus arcsine, like that. And making these graphs, when you're just working on your own, it should be pretty quick to just sort of change the formula, copy it down, and then just continually refresh the graph and just see which one starts to look straightish. Okay. Okay. And if you really wanted to get fancy, you could also try, these functions. There's all these other trig functions you can just sort of guess and check. Okay. Now here's the thing about using trig functions and guessing trig functions. They typically, not always, but typically they only work if your independent variable is an angle. okay? If your independent variable isn't an angle, you probably don't want to start out by looking for trig functions. Instead, what you might consider is this. Linearize only part of the data. This is going to seem like a really strange thing, but it's justified because of the following fact. Here's why we can do this, and this is very, very important. It's something that you want to think about and discuss in your report should you take this path. The thing to think about and discuss is data sometimes follows two or more trends. So let's say you've got your dependent variable and your independent variable, and the data sort of maybe does something like this, right? It sure sort of looks like there's one trend here and then another trend there. Two trends. So what would you do? You would select a portion of the data, maybe this portion B, and it's good to, you could even mark up your graph the way that I'm doing right now. Highlight with marker, with red ink or something, highlight the two trends that you see in your data. Call one trend A, call the other trend B. And then choose one of the two. Choose subset. So the whole data makes a set, and A and B are subsets. So choose subset A or B, and do your log, and or semi-ln analysis just on A or just on B. Then what you'd be doing is finding an equation, a function for the subset. So you would do a log with the subset. This would be just B alone. Then you would get your final function graph where it's a straight line with D versus a modified independent variable. And this again is B alone. And then you would do your max and min slope lines, max and min. You would propagate your uncertainties just in B alone, and not with any of the other not with trend A, which you discarded. Or if you choose to do A and not B, then you would just ignore B, and every time you did the follow-up analysis, you would use only A. This kind of approach has to be accompanied by some serious thought and some really, really careful consideration. So things to reflect on. If you take this approach. Things to reflect on. What caused the two different trends that you saw in the data? Or if not, what caused the trends? Another way to think, this is the same question, I'm just phrasing it a different way. What caused the data to suddenly follow a new trend? And this is something that you want to, there are oftentimes really practical reasons why this could happen. For example, maybe you changed your procedure or your design procedure halfway into the experiment, and that's when your data switched and started doing something else. Maybe you're not really sure, but you collected data. Data was collected over 2 days. Does that correspond with the two different trends? One trend was on day 1, the second trend was on day 2. And then if so, think about what you could have changed in the procedure from day 1 to day 2. Another reason is there are different physical factors at play over different ranges. I mean, after all, if you do an experiment where you're dropping a ball, if you drop it from a really low height down here, air resistance is not a factor. No air resistance. But if you drop it from a really high height, like maybe you're at the top of a 10-floor building, now air resistance does become a factor. So doing this experiment is it has different physical factors as compared to this experiment, and that difference in what physical factors are at play could produce two different trends. So there could be physical considerations as well as procedural considerations. So what would your report look like? You would still present the log analysis and or semi-ln, probably good to do both graphs for all of your data. Then you would say, you would say something like, because these aren't straight, I decided, if you choose to linearize a subset, then you have to point out what the two trends are. So you would show the graph and say, this is one trend, here's a totally different second trend, or trend A and trend B. It's nice to label them, trend A and B. That makes the rest of your report a lot easier. So you would identify the two trends, choose one, and do the log again. Or if log doesn't get you anywhere, you could just do the ln. You could just present the semi-ln if that's the one that gets your final function. So then you do that with the subset that you chose, and then you continue all data analysis. With the subset. Once you've done that, in the evaluation and conclusions, I guess it's conclusions that come first, right? And then you evaluate the procedure. In the conclusions, that's where you would really get into what produced the two trends. Physical factors, procedural changes, things like that. So in the data analysis, there's two different approaches you're taking. In the data analysis, right here, you are providing justification for using a subset by pointing out graphically, visually, here's one set, here's another subset. So here's one subset and another subset. They are two different trends. You are using visual evidence by just looking at the graph. Then down here in the conclusion, you are using, you're justifying again, or considering what could have produced. Here now you're looking at causes for the two trends. What could have caused them to occur? So I would recommend, when you're in the data analysis piece, don't talk about causes when you're doing your data analysis. Just say, to me, it looks like there are two different trends. I can see one here and one here. And then when you get down into conclusions, that's where you bring to bear different things that happened in the experiment, different possible causes. So keep those things separate. And this is what you can do if you don't have a straight line, if you can't get a straight line from just your whole data set altogether.